This video is called the 3-4-5 rule, and it's playing around with a bit of a thing called Pythagoras' theorem. This is a really important little thing to learn for building, mainly because when you want to put in a wall and things like that, you want things often to be 90 degrees, or nice and square, and we're going to see the importance of this in a little bit. This video was made using SketchUp, a good little Google program. Now what I'm going to start off is just by putting up the way that you actually can work out how to put things and make things square when you're actually doing it in reality. If you have one wall which is 3,000 millimeters or 3 meters, another one which is 4,000 millimeters or 4 meters, the diagonal there altogether should be 5,000 millimeters or 5 meters exactly. That's if your square, if your angle between the 3 and the 4 meter there is in fact exactly 90 degrees. Now this can be written using maths as this little formula called a squared plus b squared equals c squared. Now we can look at why this is the case, and we will do that in a little bit. The first thing which is really important for you to know, the very most basic thing, is that for the two shorter sides, if you ever want to square up a building, if you measure out 3 meters along one side, you measure out 4 meters along the other side, the diagonal there should be 5 meters, and if it is, and it's exactly 5 meters, this means that your wall there should be on exactly 90 degrees and everything should be good. So we'll look at why this a squared plus b squared plus c squared thing works. Well, very first off, if we substitute in the numbers, a squared becomes 3 squared plus 4 squared equals 5 squared. Now we work this out, 3 squared is 9, 4 squared is 16, 9 plus 16 gives us 25. Now 25 is 5 squared, so this does work. So this rule, this 3-4-5 rule, this Pythagoras' rule, whatever you want to call it, is a great way for getting your building nice and square. And I'll show you why this is so important. Pretend that my angle is not 90 degrees. Pretend we're a little bit out, we're a little bit rough, and we're out by 1 degree. Okay? We'll go out by 1 degree, you can see it's drawn there. Then what I'll do is I'll put on a building that's, say, 10 meters by 10 meters big. We'll see what effect this actually has over a wall length of 10 meters. So what we'll do is we'll spin around and have a look up close at the wall most affected by being out by a mere 1 degree. It will show you the importance of having your house properly squared up when you do it and really not cutting any corners, getting this exact. So what you'll see is it throws us by 1 degree over 10 meters, throws us 17.5 centimeters or 174 millimeters out. Okay, this is huge. This can cost you a lot of money if you're a builder, and it can cause a lot of aggravation. So it's really, really important that you spend the time getting this right when you're first laying out a house by using this 3-4-5 rule. Now to be even more exact over the course, what you could actually do is you use Pythagoras' theorem, and we'll use this for our 10 by 10 meter room now. So to work out this unknown diagonal here, first off I'll just mark on the 10 meters. What we're going to use is a squared plus b squared equals c squared. Now it really actually doesn't matter which one you call a or b, just so long as the long side is the c. A squared becomes 10 squared, b squared becomes 10 squared. 10 squared is 100, so 100 plus 100 is c squared. Now 100 plus 100 is 200, so c squared is 200. So to work out what c is, we have to work out the square root of 200. Now the square root of 200 is 14.1421 meters, which is the same as saying 14,142 millimeters. And as you can see, if we work it out using SketchUp, in fact that's the right amount. So we'll look at one more example using Pythagoras' theorem. Okay, so say we start with one side length, it's 15,000 mil. Another side length, it's 18,000 mil. What will the diagonal of this be? So the first thing I'm going to do is change these across the meters, okay? And then I'll just write out the rule. A squared plus b squared equals c squared. Again, the longer side, the diagonal side, is going to be the c. So in this little example here, a squared becomes 18 squared, b squared is 15 squared, and c squared is c squared. Okay, so 18 squared, 18 times 18 is 324. 15 squared, 15 times 15 is 225. This equals c squared. So we add a squared and b squared together, the answer we get is 549. So c squared is 549, so therefore c is the square root of 549. So c equals 23.4307 metres. If I convert this to millimetres, c is 23,430.7 millimetres. Anyway, that's how to use the 3-4-5 rule, as well as Pythagoras' theorem, to square up your buildings. And as you'll probably see, this is a really, really crucial thing to do. Okay, bye.